The evolution of drones from unreliable military technology to a commercially available and booming industry has found its influence grow in agriculture, healthcare, personal autonomous package delivery, civil surveying, defense, and law enforcement. None of this would be possible without the growing technology of the flight controller. The flight controller, essentially the brain of the drone, uses a variety of precision measurement devices to make complex tasks much simpler through millisecond calculations and their resultant motor responses. Of the many sensors utilized in drone flight controller technology, 3 in particular are the primary inputs for stability, navigation, and agility. MEMS, microelectric mechanical system accelerometers, measure the displacement of a given mass to calculate the magnitude of acceleration along a given axis. Conceptually, this is accomplished using a mass, damper, and spring configuration, the real-world equivalent being integrated into the chip's IMU circuit board. As the mass flexes due to the changes in velocity of the drone by external forces, the IMU circuit, and thereby the flight controller, can make corrections to produce a desired outcome. By adding more accelerometers along different axes, the changes in acceleration help determine the position of the drone with respect to the ground, its desired trajectory, and its external rotation, which refers to the pitch, roll, and yaw of the drone during flight. The 3-axis gyroscope uses a vibrating mechanical element to detect angular velocity along a particular axis. A lack of moving parts and use of integrated circuit manufacturing allow for miniaturization of the sensor into a format much smaller than that of alternative mechanical, laser ring, or fiber optic formats. The last sensor on this list is the magnetometer, used in navigation to distinguish the longitudinal heading of the aircraft's nose by measuring the strength and direction of magnetic fields. Together, these sensors form the main components of the IMU, Inertial Measurement Unit, responsible for providing the flight controller with information necessary for accurate course corrections to reach a desired trajectory. This is accomplished in quad drones by spinning certain propellers at different speeds, or in the case of missiles, by increasing or decreasing rocket thrust while changing the angle of attack of its fins. Combining the IMU with GPS or radar tracking results in sensor fusion, where the flight controller uses a variety of different measurement systems to finely tune motor control and limit resulting error from outside interference. Drone fusion and accuracy is particularly important in ICBM missile trajectory, where threat rockets go through 3 stages of flight with the goal of penetrating enemy defensive rockets and detonating on a designated target. Military drones and missiles often implement laser ring or fiber optic gyros, as they provide greater precision and reliability in environments that often encounter severe shock during transportation, launch, staging, deployment, and engagement.